Hi, it's Mr. Anderson, and this is AP Physics Essentials 25. It's on gravitational field strength, which is a measure of the gravitational force placed on an object that's in a gravitational field. And so you know that the moon orbits around the Earth and stays there because of this gravitational field. And so if we place it in orbit, watch how the force on those two objects remains constant. The gravitational field strength is the same. But if we were to play around with this PHET simulation, if we move the moon closer to the Earth, you can see the force is increasing. It has greater strength. And as we move it away, it becomes less. How else could we change the gravitational field strength? Well, we could increase the mass of the moon. It's a greater force. We could increase the mass of the Earth as well, and there's going to be a greater gravitational field strength, and it's going to have catastrophic consequences when we put it in orbit. And so remember, any object that has mass is going to generate a gravitational field. And those field lines are going to point to the center of that object. And so any object, and we'll just deal with spherical objects in AP Physics 1, is going to have a gravitational field that's going to become greater the closer we come to that object. And so if you want to calculate the gravitational field strength, this equation works. And it was developed by Sir Isaac Newton. And it really only has those two things that we saw in that video. It's the mass of the object and then the radius, or the distance between that object and a point. Now you might say there's three things in this equation. The first one is a gravitational constant. We lots of times refer to that as big G. But the other two things that are going to affect the gravitational field strength are the mass of the object and then the radius, or the distance from the object. And so in this class, you should be able to calculate the gravitational field strength of an object or sitting on the surface of a really large object like the planet. And so gravitational field strength, this is our equation right here. There are three parts to it. And so if we're measuring the gravitational field strength at a point separated from that object, we need to know the mass of the object. We need to know the radius. And note this, that when we're looking at the radius, it's not from the surface of the object, it's from the center of mass of both objects. In this case, one is just a point. And then the last one is going to be the gravitational constant, or big G, and that's just 6.67 times 10 to the negative 11th. And then we got a bunch of units coming in after that. And so let me give you an example problem. Let's say I want you to figure out the gravitational field strength of a baseball. You could imagine it's going to be really, really small. There's not much mass in it. But if you want to solve this problem, I haven't given you enough information. You need to know what's the mass of that object. It's 0.145 kilograms. And you also have to know how far away is it. And let's say it's 2.0 meters. And so you maybe have forgotten what big G is, so we'll put that right up there. 6.67 times 10 to the negative 11th. And so you may want to pause the video right now and try to solve this problem. Or you could just watch me do it. I'm going to take those three values and I'm going to place them into my equation. So I'm taking the big G times the mass divided by the radius squared. And so when I solve that, I get a gravitational field strength, or a G, of 2.4 times 10 to the negative 12 newtons per kilogram. If we cancel out all those units, we've got newtons on the top, we've got kilograms on the top, but we've got kilograms squared on the bottom, so we're going to end up with 1 kilogram on the top, and then the meters squared are going to cancel out. And so that's going to be the gravitational field strength of the baseball. Incredibly small, but it's still there. Let's say we were to do this. Can you figure out the gravitational field strength of the Earth? So we're sitting on the surface of the Earth. Can you figure out what's the strength of that force pulling you or holding you on the planet? Well, again, you'd need two more things. We're going to need to know the mass of the Earth, and it's pretty massive, 5.97 times 10 to the 24th kilograms. And you also need to know how far are you from the center of the Earth? What's the radius of the Earth? And it's 6.37 times 10 to the 6 meters. And so to solve this problem, you're going to do the same exact thing. We're going to plug it into those equations, those values. And again, it's worth doing, but if you do this, you're going to get a value that you've seen before. The gravitational field strength is going to be 9.81 newtons per kilogram. And so that is going to be the gravitational field strength as we get close to the planet. Again, it's also numerically equal to the acceleration due to gravity on our planet. And you might say it's going to be the same everywhere on our planet, but it's not. If you look at the gravitational field strength on our planet, and this is a NASA image, It's going to vary depending on where you are. Because the Earth isn't consistent, it's not a consistent sphere with consistent density, it's going to have differences in latitude and therefore the distance from the center of the Earth. There's going to be geological differences, what the Earth is made up of, and so we can study the gravitational field strength in different areas, and it tells us a lot about what the Earth is actually made of. And so did you learn to calculate the gravitational field strength of an object a certain distance away? And did you figure out how to approximate the gravitational field strength if you're sitting on the surface of a really large object? It's the same equation, it's pretty easy, and I hope that's helpful.